So let's have a quick revision on the chemical kinetics. So starting with rate of reaction, we all know it is the change in concentration of the reactants or products in the unit time, or we can say it is the increase in the concentration of the reactant or decrease in the concentration of the product. So what is the unit? Unit is mole liter inverse second inverse. So for any reaction A gives rise to mm, we can say the rate of reaction is equal to 1 by A into minus dA by dt, or 1 by m into plus dm by dt. So this minus dA by dt is the rate of disappearance and the plus dm by dt is the rate of appearance. So for the reactant side we'll use this term disappearance, and for the product side we'll use the term appearance. What is average rate of reaction? When we use a specific time interval, it is known as average rate of reaction, and when we calculate the rate at a particular instant of time, it is the instantaneous rate of reaction, which is the derivative of concentration of the reactant and product with respect to time. So what are the factors which are affecting the rate of reaction? The very first one is the temperature. With increase in temperature, the rate constant increases, for which the rate of reaction also increases. So every rise in 10 degrees centigrade or 10 Kelvin, the rate of reaction or the rate constant is increased by 2 to 3 times. With increase in concentration of the reactant, also the rate of reaction increases, because in rate law we are studying R is directly proportional to the concentration of the reactant. With increase in surface area, the rate of reaction also increases. Again, in presence of catalyst, it depends. The catalyst can be a positive catalyst which reinforce the reaction and increase the rate of reaction. If the catalyst is a negative catalyst, then the rate of reaction decreases. The rate of reaction is also depend upon the nature of reactant, which vary depend upon the reactants. Coming to the rate law. So what is rate law? Rate law is the expression which express the rate with the concentration of the reactant. So according to rate law, the rate of a reaction is directly proportional to the product of molar concentration of the reactants raised to some power, which are determined experimentally and may or may not be equal to the stoichiometric coefficient. So for a reaction, if we are writing A plus BB gives rise to CC, so R is expressed as K into A to the power X and B into Y. So here X may or may not be equal to A and Y is may or may not be equal to B. So what is order of reaction? It is the sum of the power of molar concentration of the reactants expressed in the rate law. So for this rate expression, the order will be X plus Y. So the next one is the molecularity. While order of a reaction is a experimental concept, the molecularity is a theoretical concept. It refers to the number of molecules that participate as reactant in an elementary reaction to give product. So it is a completely theoretical concept. For this reaction, the molecularity will be A plus B if this reaction is a elementary reaction. For a complex reaction, molecularity has no meaning, and for complex reaction, the rate is determined from its lowest step, from which the order can be calculated. Next is the integrated rate equation. For zero order reaction, that means R is equal to K into A to the power 0. That means the rate does not depend upon the concentration of the reactant, while the rate is equal to rate constant. So from this we can derive the rate constant is equal to R0 minus RT divided by T, where R0 is the concentration of the reactant at time T is equal to 0 second, and RT is equal to concentration of the reactant at any time T. So from this, if we calculate the T half is equal to R0 by 2K, and the rate of the unit of rate constant, that will be mole liter inverse second inverse. Next one is the integrated rate equation for the first order reaction. For any first order reaction, we know R is equal to K into A to the power 1. Here the rate is directly proportional to the concentration of the reactant. So from this, if you derive the value of K, it will be 1 by T ln R0 by RT, or 2.303 by T log R0 by RT. If you derive the T half value, it may be called as 2.303 log 2 by K, or 0.693 divided by K, we will use these formulas according to the question. If the K value is in the multiple of 693, we will use this formula. If the K value is in the multiple of either 3 or 2.303, we will use this formula. And for the first order reaction, the unit of K is equal to time inverse, or we can say second inverse. So what is rate constant? Rate constant is the proportionality constant in the rate law equation, or you can say the rate constant, which is also the specific reaction rate, that is the reaction rate at a specific condition. So what is that? It can be defined as the rate of reaction when the molar concentration of the reactant is taken as unity. So for the rate law expression, that is R is equal to K into A to the power X and B to the power Y, if the concentration of A and B is taken as 1, then R is equal to K. So this R is equal to K at condition the concentration of all the reactants is 1. So from this we all know what is the unit of K. It is the general formula, that is mole liter inverse to the power 1 minus n into second inverse. So n is the order of reaction. So if we are provided with the unit of K, let it is given as mole to the power x, liter to the power minus x, and second inverse. So from this, how we can calculate the order? We have to look at any one power. Let consider this x value. So order of reaction is equal to 1 minus x. Next one, the order of reaction for a reactant which was absorbed on the metal surface is always 0, because when this reactant is absorbed on the metal surface, with increase or decrease in the pressure, the concentration of the reactant which absorbed on the metal surface do not changes. Hence the order of reaction does not depend upon, or the rate of reaction does not depend upon the concentration of that reactant. Hence the order of reaction according to the reactant is always 0. For example, the decomposition of ammonia using platinum catalyst. Here the ammonia is absorbed on the platinum catalyst whose concentration does not vary in a particular interval of time. Hence the order of reaction is 0. Similarly, the thermal decomposition of HI on gold surface. Here also the concentration of HI does not vary in a particular interval time. Hence it is also a 0 order reaction. If we talk about hydrogenation of ethene in presence of nickel, platinum, palladium, here the hydrogen is absorbed on the nickel, platinum or palladium. Hence the concentration of hydrogen does not vary in a particular interval of time, and the rate of reaction depends upon the concentration of ethene. So the order of reaction will be 1. So it is a first order reaction. All the radioactive disintegration reactions are first order reaction. Also all the thermal decomposition reactions are also first order reaction, conditions provided if no metal surface are used or if the reactants are not taken in excess. When a reagent taken in excess, the order of reaction with respect to the reactant is 0. For example, the hydrolysis of ester or inversion of cane sugar, both are pseudo first order reaction because the water is taken as excess, so rate of reaction does not depend upon the concentration of water. The temperature dependence of rate of reaction, which is the Arrhenius equation but proposed by J.S. Van 't Hoff, but physically justification and interpretation given by the Arrhenius. So what is that equation? K is equal to A into e to the power minus A by RT. So we can say the ln K is equal to ln A minus A by RT, or log K is equal to log A minus EA divided by 2.303 RT. This K is the rate constant, A is the pre-exponential factor or Arrhenius factor or frequency factor, e to the power minus EART is the fraction of molecule which overcome the threshold energy. So for two different K value at two different temperature, the equation is log K2 by K1 is equal to EA divided by 2.303 R whole into T2 minus T1 divided by T1 T2. This 2.303 R we can take in it as 19.15 to calculate the question very faster way. The value of R is equal to 8.314 joule mole inverse Kelvin inverse. So the value of energy we will get in the joule. We may convert into kilojoule as per the question. The next one is the collision theory. So according to collision theory, effective collision gives rise to product because at a room temperature a number of collisions happen but only effective collision gives rise to product. So a collision is a effective collision if it satisfies two conditions, that is energy barrier and orientation factor. Energy barrier, it is the minimum energy required to overcome threshold energy, and what is the orientation factor? Even if the molecule have the threshold energy, it will not give product unless and until it is oriented in a proper way. So from this we derive the formula that R is equal to P ZAB into e to the power minus A by RT. P is the probability or steric factor, ZAB is the collision frequency, and we have already discussed this e to the power minus A by RT is the fraction of molecule overcomes the threshold energy. So what is this collision frequency? It is the number of collision per unit volume per second, that is ZAB, which is the collision frequency. Let's discuss some graphs. So for a catalyst does not alter the value of del G or del H, rather it decreases the activation energy and provide a newer path for the reaction. So this is the graph for an exothermic reaction. Exothermic reaction, because the energy of the reactant is greater than the energy of product. So if this is the actual path of reaction and we will use catalyst, the catalyst will provide a newer path and will not alter this del H value or del G value. It will provide a newer path and increases the rate of reaction by decreasing the activation energy if the catalyst is a positive catalyst. Again, if you analyze the graph, the del H value is equal to energy of the product minus energy of the reactant, which will be negative because energy of product is less than the energy of reactant, so it is an exothermic reaction. Again, we can say this del H is also equal to activation energy of the reactant. This is the activation energy of the reactant minus activation energy of the product. So as the activation energy of the product is a larger value, so this will again give a negative value. So what is the threshold energy? It is the minimum energy required by the molecules to overcome the energy barrier, and threshold energy is equal to activation energy of the reactant plus energy of reactant, or activation energy of product plus energy of the product. So again, this is the endothermic curve. For an endothermic reaction, the del H value is positive. So if we calculate the value of del H, which is equal to energy of product minus energy of reactant, it will give a positive value as EP is greater than ER. Similarly, we can also use the activation energy. The del H is equal to activation energy of the reactant minus activation energy of the product. Again, it will also give a positive value as the activation energy of the reactant is larger than the activation energy of the product. Again, the threshold energy, which is equal to activation energy of the reactant plus energy of the reactant, or activation energy of the product plus energy of the product. Next, come to the curve of Arrhenius. If you plot a curve for the Arrhenius equation, from the Arrhenius equation we know the ln k is equal to ln A minus EA by R T. So if we equate this equation with a linear equation, y is equal to C plus mx. So 1 by t is equal to x and ln k is equal to y. So intercept is a ln A, which is a positive intercept, and slope is equal to minus EA by R. So here the slope is equal to minus EA by R. Similarly, if we plot the graph for log k and 1 by t, the slope will be minus EA by 2.303 R. Next, come to the fast order reaction plots. We all know R is equal to K into A to the power 1. So R is directly proportional to A. So this will give a straight line when we plot the graph of R versus A with a slope of K. Similarly, if we plot a curve for ln R versus T, it will give a slope of minus K. We all know that K is equal to 1 by T ln R0 by R. So Kt is equal to ln R0 minus ln R. So this becomes ln R is equal to ln R0 minus Kt. So this is y. Again, T is the x. So this will be m and this will be c. So the intercept will be ln R0 and slope is equal to minus k. Similarly, if we plot the graph for log r versus t, this will give a slope of minus k divided by 2.303. Again, if we plot the graph versus r0 by t half for first order reaction, we all know t half is equal to 0.693 divided by k, which does not depend upon the concentration of the reactant, so it will remain constant for any value of r, which is 0.693 divided by k. If we plot the graph of ln r0 by r versus t, it will give a positive slope that will be k and intercept that will be 0, which will pass through the origin. We all know that k is equal to 1 by t ln r0 by rt. So ln r0 by rt is equal to kt. So this is y, t is x, so k is equal to m and c is equal to 0, which will pass through origin. Similarly, if we plot the curve of log r0 by r and t, it will give a positive slope that will be k divided by 2.303. Last one, plot for the zero order reaction. If we plot a graph for r and concentration of A, we all know for zero order reaction r is equal to k and A to the power 0, so it does not depend upon the concentration of the reactant. So for any value of A, the r will remain constant for a zero order reaction. If you plot a curve of r versus t, we all know k is equal to r0 minus r divided by t, so kt is equal to r0 minus rt, or rt is equal to r0 minus kt. So this is y, this t is x, so minus k will be m and r0 will be intercept, a positive intercept, that is c. So it has a positive intercept with slope negative. Again, if we plot a graph of r0 versus t half, we know the formula, t half is equal to r0 divided by 2k. So if we plot the graph of t half versus r0, we will get a slope that will be, because r0 is equal to t half into 2k. So this is y, this is x, this will be m, so slope is equal to 2k. So these are some concepts from chemical kinetics. You can practice more problem and surely you will get a good result in your board. Thank you. Happy learning.